Good evening, students. Today's topic is grade 12 chemistry, chemical kinetics. In that, the first subtopic, rate of reaction, we are going to discuss. When you see the term called chemical kinetics, the kinetics is derived from kinesis, which means movement. So, because of this, we can define chemical kinetics like this. So, the branch of chemistry which deals with first one, rate of reaction. We will discuss about rate later. Now, second one is what are the factors which are influencing the rate of a reaction, and third one is very important, reaction mechanism. So already in grade 11 we have discussed what exactly is a mechanism. The various steps involved in a particular reaction can be termed as mechanism. So this is about the definition of chemical kinetics, where you will study about rate of a particular reaction and what are the factors which will influence the rate, and third one is reaction mechanism. Now, when you talk about the reaction, we have three types. Based on the velocity of a reaction, you can also term it as a speed. That means the time taken for that particular reaction to complete is nothing but its velocity. So we have three types here. What are those three types? First one, very fast reaction, or you can also say instantly the reaction completes. So therefore, we can say instantaneous reaction. So what is the first reaction? It's very fast, completes within fraction of seconds, and you call it as instantaneous reaction also. Second one, a moderate reaction. A moderate reaction takes in some few minutes. And last one, very slow reaction. This reaction will complete in months or sometimes in years also. We can understand much better by taking the examples. The first one, let us talk about very fast reactions. What are those fast reactions? Right from lower classes, we are discussing about neutralization reactions. Right. First one. What is neutralization reaction? The reaction between an acid and base. So let us take example HCl as acid and base NaOH. Now the product is salt plus water. So this takes place immediately. So in few seconds. So we can say that it is a very fast reaction. One more example you have, conformatory test for halogens. During salt analysis we will do the conformatory test for halogens. So example, you take Cl. So what is the name of the test? Silver nitrate test. Example, you take NaCl. So here we have the halide Cl minus. Adding AgNO3, Ag plus. Immediately the reaction takes place within seconds, and you will get the product AgCl, a white precipitate. Along with that you will get sodium nitrate. So we can understand by this two reactions, neutralization as well as silver nitrate test, that some reactions like this will complete very fast, and those are called as very fast reactions or instantaneous reactions. Now second one, moderate reaction. So what is meant by moderate reaction? The velocity is moderate. So first one, we have completed very fast reactions. Second one is moderate. Example 1, you take carbon monoxide plus chlorine gives you carbonyl chloride. So this reaction takes place in some few minutes. Second example, you can take inversion of cane sugar. So what is inversion of cane sugar? C12H22O11 plus water. So this is cane sugar or sucrose. In presence of water, what happens? It gives us glucose plus fructose. So we have got the glucose and fructose by inversion of cane sugar. This will take some time, hence you call it as moderate. Now one more reaction you have, that is decomposition of hydrogen peroxide. So decomposition of hydrogen peroxide. We again know that peroxide oxidation state of O is -1. So how it decomposes? So 2 moles H2O2 will decompose into 2 moles water and O2. So this will complete not very quickly, but it takes some time. So due to this, we can say that they come under moderate reactions. Now the last one is very slow reaction. Most of us are familiar with rusting of iron. So what is rusting of iron? So if you take iron in presence of moisture as well as atmospheric air, it will convert into brown rust. So the equation is 4Fe plus 3O2 in X moles water gives 2Fe2O3 dot X H2O. This is nothing but rust. Depending upon the moisture as well as oxygen, it takes lot of time, sometimes months also, to convert into rust. So this is coming under very slow reaction. So hope you have understood. So why we are discussing these three types of reactions here? Because we have to get into rate of reaction, rate or speed of the reaction, in which we can see some important examples. Now, what do you mean by rate of? In physics also you would have seen, suppose you are talking about velocity, then you will say a rate of change of displacement, and that is nothing but displacement by time. So any physical quantity, if you are comparing in terms of time, then you use a term called as a rate of. So now, in a reaction, what is meant by rate? So very important topic to discuss, that is nothing but rate of a reaction. So if you want to calculate the rate of reaction, we can write like this: the change in concentration of reactants or products. See, if you are taking any reactants and products, we can represent the concentration in square bracket, that we know. I will write the equation later. So change in the concentration of reactants or products divided by the time taken, hence we call it as rate of, divided by the time taken for that particular change is known as rate of reaction. So let us see here. Suppose you are taking this one, A is converted into B. So in this condition, the reactant is A and the product is B. How do you measure rate here? Let us understand that initial concentration is A1 and final concentration is A2. So A1 is initial, A2 is final concentration. Therefore, change in the concentration. So how to write? Final concentration minus initial concentration divided by T2 minus T1. So initial concentration is at time T1, final concentration is at time T2. Therefore, we can write like this. So hope you have understood. So this is nothing but rate, that is change in concentration of reactants or products. So that we will discuss now. One more important thing is, if this is in gaseous state, first one was in solid or liquid state, now if at all it is in gaseous state, how to measure the concentration? If it is in gaseous state, we can write in terms of partial pressure. And how do you measure partial pressure? Generally it is measured in atmosphere. So now let us write the units for this. So first condition, we know that the concentration, what are the units of concentration? Concentration is measured in terms of moles per liter, and time we can measure in terms of seconds, or you can also measure in terms of minutes here. Now in the gaseous state, partial pressure is represented as atmosphere, hence the units can be written like this: atmosphere per second or atmosphere per minute. So hope you have understood this. This is a simple formula how to calculate the rate of a reaction. Now, what are the types of rate? So how do you measure that? So we can measure the rate of reaction in two ways. What are the two ways? So the first one, very important, we call it as average rate of reaction. Average rate of reaction. And second one is instantaneous rate of reaction. See, it says average. That means particular time interval, you may take it as from a particular time T1 to T2. In between this, what is the rate of reaction? But at a particular instant, that means at particular time. So maybe the time T is equal to 10 seconds, like that. So at 10 seconds, what is the rate of reaction? If you measure, then that is nothing but instantaneous rate of reaction. So hope you are understanding this. So with the examples we can calculate. Number one, average rate of any reaction. So if you are talking about average rate of reaction, you have two types. First one is the reactants and the products have same coefficients. You know what is a coefficient? If they have same coefficients. And second one, if reactants and products have different coefficients. So how to measure that? So in the previous case we have taken like this: initial concentration, if you write initial concentration is A1 at a time T1 and final concentration is A2 at time T2. So for A to B, so you have considered the reaction A to B and we wrote like this. And in that, if you want to write average rate, so the formula is as it is. What we write is concentration, final concentration minus initial concentration by T2 minus T1. You know that whenever you are taking the difference or change, you will write it as delta. So delta concentration of A by delta T. So this should be the formula to calculate average rate of reaction. Now one more important thing, whenever you see the reactants will get decreased. Example, I am just taking as an example. Initially, let us take it is 2 mole per liter. After some time, the concentration decreases for the reactants because it is converting into product. So let us take 1 mole per liter. Now what is delta now? Delta is nothing but A2 minus A1. 1 minus 2, that is equal to minus 1. So always remember, whenever you are calculating the average rate for a reactant, it should be represented as minus. The reason is concentration gets decreased. And example I told like this. So initially 2, final is 1. If you take the difference, it will be in negative. Hope you have understood this. The same thing, if you want to write for B. So how to write for B? Let us take in the beginning, initial concentration is B1. So that particular moment only 1 mole per liter is formed. After some time, if you take final concentration after some time, which is B2, you got increase in the concentration, that is nothing but 2 mole per liter. Now when you are writing this average rate, what will be delta B now? Final minus initial, nothing but 2 minus 1, which is plus 1 here. So hope you have understood this. When you are writing for the reactants, you will write minus, and when you are writing for the products, you will write positive. So we can write like this, that can be written as concentration of B2 minus B1 by T2 minus T1, which is equal to plus delta concentration B by delta T. So here minus for reactants, plus for products. Hope you have understood this. Now the same thing we are applying for two types of average rate, that is with the same coefficients and with the different coefficients. So let us take example 1, that is CO plus Cl2 gives COCl2, and example 2, decomposition of PCl5 to form PCl3 plus Cl2. So I have taken two examples. Now let us write the average rate for these two. So important thing, we can see that both these reactions have same coefficient. So let us see 1, here also 1 coefficient, here also 1. PCl5 1 mole, PCl3 1, Cl2 1. For that, it's a normal method, easily we can write average rate is equal to minus because it is reactant, concentration of CO, delta CO by delta T. That is again equal to minus delta concentration of Cl2 by delta T. Now when we come to the product, that is plus delta concentration of carbonyl chloride by delta T. So there is no much difference, we can write according to the formula of average rate. Now PCl5, once again PCl5 is the reactant, therefore average rate is equal to minus delta concentration PCl5 by delta T. Coming to the products, we will have plus delta concentration of PCl3 by delta T, which is equal to plus delta concentration of Cl2 by delta T. So hope you have understood this. So average rate can be this one, second and third, any one, all are equal. So this is about the first condition. Now let us take the second example where you have different coefficients. What is the changes we are going to make in this? Two examples we can consider again. First one, Haber's process. Haber's process. N2 plus 3H2 gives 2NH3. And decomposition of N2O5. So, second example is decomposition of N2O5, nitrogen pentoxide. So the equation is 2N2O5 gives 4NO2 plus O2. Now different coefficients of reactants as well as products, here also the same, how it is 1, here 3 is the coefficient, 2 is the coefficient for ammonia, here 2, 4 and 1. In such cases, always remember that we have to write a rate, average rate is equal to 1 by coefficient, this we have to add. In the next one is same, so delta, the concentration of reactants or products by delta T. So hope you have understood. We have to represent 1 by coefficient in this condition. So with this Haber's process, how do you write average rate? Now reactants are there, therefore we'll write coefficient is 1, so no issues here, 1 is there. So minus delta concentration of N2 by delta T. First one is fine. Now the coefficient is 3, therefore we have to write 1 by 3, 1 by coefficient into delta H2 by delta T. This is very important here. Now we are coming into the products side, coefficient is 2, therefore 1 by 2. So this is 1 by coefficient into, as usual you will write delta NH3 by delta T. Hope you have understood the difference when you have different stoichiometric coefficients. That is, now in the second example we can easily write this is 2, coefficient is 2, therefore average rate is equal to, as usual, minus, because it is reactant, 1 by 2. Why did we write 1 by 2? Coefficient is 2, we have to write 1 by coefficient into delta concentration N2O5 by delta T, which is equal to product. The product is represented in plus and 4 is there, hence we will write 1 by 4. So 1 by coefficient into delta NO2 by delta T. Now the last one, oxygen, coefficient is 1, so therefore 1 by 1, it is okay, plus delta O2 oxygen by delta T. So this is the method to write average rate of reaction in terms of different coefficients of the reactants as well as products. I think you are clear with this. Now the last point we will mention here, that is a general equation we can write. A general equation for average rate of reaction, how to write that? So we have seen both the types, that is with the same and different coefficients. So a general equation for average rate. Let us take, this is the equation giving us C plus. Now small alphabets indicates the coefficient, capital alphabets indicates the concentration. So that is reactants as well as products. How to write this? Average rate is equal to, now the reactant side minus, now the coefficients always we will write 1 by coefficient. 1 by coefficient. So A is there, therefore 1 by A into delta concentration of A by delta T. That is equal to minus 1 by B into delta concentration of B by delta T. Okay. The same way, if you are writing for the products, it will be plus, coefficient is C, so 1 by C into delta concentration of C by delta T. The last one, product, hence plus, coefficient is D, therefore 1 by D into delta concentration of capital D by delta T. So this is a general equation. So any reaction you will get, you can write average rate of reaction by using this representation. So hope you have understood this first one, that is average rate of reaction. Now second one, according to the definition just now we have seen, right, at a particular time, this is, we are having some time interval, but if you take instantaneous rate, it will be at a particular instant. Example, maybe at 10 seconds or 11th second or 12th second, like that. What is the major difference actually? Instantaneous rate of reaction. Now whenever you are talking about average rate will be, if you take A is converted into B, after a certain time what happens? The concentration of A decreases as certain time is increased. So therefore what will happen when you are writing like this, average rate is equal to, delta A will be there. Both are directly proportional. What will happen if the concentration of A decreases? The rate also starts decreasing. But it is not correct, right? Anyhow, if you are taking the rate of reaction, generally it should not decrease. So therefore, what we do is, don't take for more time. That means between some time you don't take. What you should do is, you have to take at a particular time. At a particular time. So that can be written like this. Small interval of time. Small interval of time. Very small interval of time you can consider, in which if you take T2 minus T1 should be approximately equal to 0. So where you will write it as dt. Very small interval of time can be written as dt. So the advantage of instantaneous rate is we can find out in a very small interval of time, not like average rate where you will take more and more amount of time interval. Fine. How to write this now? If I use instantaneous rate, the method is same. Let us take A is converted into B. Now I will write minus concentration, very small difference here, that is a D. dA by dt is equal to plus of very small change in the concentration of B by very small interval here like dt. So therefore we can write like this: instantaneous rate, instead of writing average rate, where you are rating it as minus delta large difference by large difference in time, which is equal to plus delta b by delta t. So this is the difference between instantaneous rate as well as average rate, where you take more difference and here you will take very minor difference. So hope you have understood this. Now let us solve some numericals. So now the review exercise questions what we have is 4.3 and 4.4. Here they are asking you to calculate average rate for the three equations. So with the given information we know how to calculate. So let us see that first one. Now the reactant, so therefore minus, we can write like this: average rate can be calculated as minus 1 by 2 because coefficient is 2 here, delta concentration of NO2 by delta T. For F2 only 1, so no need to write the 1 by coefficient here. So straight away we write minus delta concentration F2 by delta T. The product, once again you have the coefficient 2, so therefore we will write 1 by 2, and you know because it is product we have to write a plus concentration of NO2F by delta T. So this is the average rate of reaction for this. Now second one. So H2 plus I2 and 2HI, only here you have coefficient. So we can write like this: average rate is minus delta H2 by delta T. Similarly, minus delta concentration of I2 by delta T. Now in this plus 1 by 2 delta concentration of HI by delta T. Now the last reaction, again coefficient is 2 and here 2. So we can write like this: average rate is minus 1 by 2 delta concentration of ICl by delta T. Again H2 is reactant, minus delta H2 by delta T. And now the products both are positive. So plus delta I2 by delta T is equal to plus 1 by 2 because coefficient is 2, it is 1 by 2 delta concentration of HCl by delta T. So using this we can write the average rate of reaction for this. Hope you have understood this. Now the second question is, they have given a reaction. In that, rate of disappearance is there. So with that information you have to calculate the rate of the reaction. How to do that? First let us see. If I write for A, what is the rate? The rate is written as 1 by 2, nothing but here minus 1 by 2 into delta A by delta T. In this rate, when you talk only this particular term, that is nothing but rate of disappearance, because it is disappearing, it is decreasing for A. Even B also will be rate of disappearance. But when it comes to D, for example 3D, that also we can write coefficient is 3. So plus 1 by 3 into delta concentration D by delta T. Only this particular term, here this term and here this term, is rate of appearance. You can also call it as formation. So we are having the product formation. So hope you have understood this. First we will write the rate as usual. In that, don't consider the coefficient. Only this term is nothing but either disappearance or appearance. So with the given information, we need to calculate appearance of D as well as the rate of the reaction. So first, let us write rate of reaction. We already know this. The equation is minus 1 by 2 into delta A by delta T. In that, what is the rate of disappearance? Only this part. So that is equal to minus 1 by 2 into how much is the value? 0.1. Fine. So therefore, the rate is equal to, generally minus represents only the disappearance, or you can say reactance. You can generally represent rate in the positive terms. Now, what is the value here? 2 and 0.1, nothing but this will be 0.5 into 0.1, nothing but 0.05 mole per liter. So finally we can conclude that rate of reaction is 0.05 mole per liter per second. Fine. Next, first one is done. What is the second one? What is the appearance of D? According to that, rate is equal to plus 1 by 3 into delta D by delta T. We want to know only this. Only this term is nothing but rate of appearance of D. So what we will do? We know already rate, nothing but 0.05. Now what we do is send 3 to other side. Therefore, into 3 is equal to rate of appearance of D. So what is this now? 0.53 is 15. So 15 mole per liter per second. So hope you have understood this. We can calculate rate of reaction first, and then we can calculate a rate of appearance of D using this method. So hope you have understood this. Let us move to the next question. So now coming to 4.5, the reaction is given 2N2O5 gives 4NO2 plus O2. They are saying that the concentration of N2O5 is decreasing. So what do you mean by that? Nothing but delta N2O5. So concentration decreases is nothing but delta value for N2O5. So how much they gave? Delta N2O5 is equal to 2 into 10 to the power of minus 2. And they have mentioned the time nothing but in a period of 10 seconds. So the question is, what is the rate of reaction? So how to calculate, that is the rate of reaction is equal to, we can take this like minus 1 by 2 into delta N2O5 by delta T. Substitute that and we can get it as minus 1 by 2 into N2O5 is 2 into 10 to the power of minus 2 and time is 10. So you can cancel this. So that is equal to 10 to the power of minus 3 mole per liter per second. So first part of the question we have done easily. Only one thing what you should understand is the concentration of N2O5 decreases in the sense they have taken delta value. So time is given, so you substitute and get the rate. Now the rate is 10 to the power of minus 3. Now easily you can calculate the appearance of NO2. How do you calculate? Rate is equal to, coefficient is 4, therefore 1 by 4 into concentration NO2 by delta T. Now they are asking only this term. What is this term? This term is known as rate of appearance of NO2. That's it. So we need to calculate this. For that, already you know what is rate. What is rate? 10 to the power of minus 3 is equal to 1 by 4 into rate of appearance. To find this, send to other side of equality symbol. So what you will get, therefore the rate of appearance of NO2 is 4 into 10 to the power of minus 3 mole per liter per second. So hope you have understood this. So question number 4.5 we can solve like this. Next, Hayward's process. They have given rate of the reaction and they are asking you to calculate both disappearance of N2 as well as H2. So let us solve this. Now, so for this reaction, if I put rate, that can be written as minus delta concentration N2 by delta T. So in this particular case, rate is given as 2 into 10 to the power of minus 4. That is equal to, the whole term is nothing but rate of disappearance of N2. So very easy. You got the answer. So unit you can write mole per liter per second. So first one is very simple. Now, what about H2? The coefficient is 1 by 3. So rate is equal to minus 1 by 3 delta H2 by delta T. We want only this term. Therefore, send 3 to other side. What you will get? What is rate? 2 into 10 to the power of minus 4. Sending 3 to other side into 3 is equal to rate of disappearance of H2. So what is that? 3 into 2 nothing but 6 into 10 to the power of minus 4 mole per liter per second. So hope you have understood both 4.5 and 4.6. Let us move to 4.7. So now let us see 4.7 and 4.8. In this equation, N2O4 gives 2NO2. They are saying that because it is gas, the pressure is decreasing from initial 0.64 to 0.38. Now time is also mentioned 28 minutes. They are asking two things. One is rate of reaction, second one is rate of appearance of the product NO2. For this I have written the solution. Change in the pressure, that is initial like minus final, you will get 0.26. Next, time is mentioned 28 minutes. Rate, you know how to calculate for this, because it is reactant minus delta concentration by delta T. So we got the concentration in terms of partial pressure, that is atmosphere. So finally you will get the rate of reaction as 9.28 into 10 power minus 3 atmosphere per minute. Now when you get the first one, second one is very easy. Like how to find appearance. So rate is equal to, because the coefficient is 2, we have to take 1 by coefficient, that is 1 by 2, and plus, because it is product, concentration of NO2 by T. So this term alone is called rate of appearance of NO2. This already we know. So to find out what to do, rate, we know already 9.28 into 10 to the power of minus 3. Send 2 to the other side. So you will get 9.28 into 2 into 10 to the power of minus 3. So finally you will get the rate of appearance of NO2, that is 1.856 into 10 to the power of minus 2 atmosphere per minute. So 4.7 I hope you have understood. Then 4.8 is a very simple question. They have given 2H2 plus O2 gives 2H2O. In that they are asking the relation between disappearance of O2 and the rate of production of water. That means appearance and disappearance. Again, you know, make it as instantaneous at particular point of time. So minus d, small change here, that is d of O2 concentration by dt. Why you took minus here because it is reactant. Now coming to the product, coefficient is 2, hence we have written 1 by 2. Again, small change in concentration of water by small change in the interval of time. So this is the relation. Hope you have understood the review exercise questions. Now let us see some competition based questions. Now let us see level 1 competitive exam questions. First question says, in this equation a plus 3b gives 2c, the rate of reaction value is given. Now they are asking find minus dB by dt, nothing but the rate of disappearance of one reactant. Okay, so how to do that? So we are taking the solution for first question. So let us write this. The rate generally in terms of B, how do you write? Minus 1 by 3 into D concentration B by dt. First we will write this. Now according to the question you have to find only this, and rate is given as 3 into 10 to the power of minus 3. Now send 3 to other side, into 3 is equal to minus D concentration B by dt. So 3 into 3 will get 9 into 10 to the power of minus 3. So option B will be your answer. So hope you have understood this. Very simple. Now question number 2. They have given this reaction 4NH3 plus 5O2 gives 4NO plus 6 water. In that, rate of reaction with respect to NH3. With respect to NH3, they didn't mention appearance or disappearance. They are mentioning the complete rate. Rate with respect to NH3 is 2 into 10 to the power of minus 3. This is nothing but molar per second. If at all they are asking, it can be anything. With respect to O2, with respect to NO, and this generally we ignore because water is a diluted solution here, so we don't take. With respect to these two, what will be your rate? Rate with respect to O2 or with respect to NO will be same. So it won't change. You don't calculate taking it as 1 by 5, 1 by 4, etc. Very simple question. Here with respect to nitrogen they gave. Here with respect to oxygen also will be 2 into 10 to the power of minus 3 as such. So what is the answer here? Yeah. So hope you have understood both the questions. Now let us move to question number 3. Now let us see question number 3 and 4. So question number 3 is rate of formation of SO3. So in 2SO2 plus O2 gives 2SO3. So they have taken this equation and the rate of formation of this alone is given as 100 grams per minute. Now they are asking what will be the rate of disappearance of O2. Again same formula. Rate is equal to, if you are taking O2 because it is reactant minus, so D of concentration of O2 by concentration, that is dt, which is equal to, now coefficient is 2, therefore 1 by 2, as it is product plus formula you know you have written. In this it is given that the formation of SO3 is 100, so that we can substitute here. So this part is nothing but a rate of disappearance of oxygen, and here it is formation of SO3. So after substitution, so we can cancel 100 like this. So answer will be rate of disappearance of O2 is 50 grams per minute. Now coming to the fourth question. It is given that the concentration of that particular reaction is decreasing from 0.2 molar to 0.05 molar in 5 minutes. Observe here they have given time in minutes, but they are asking the rate in terms of per second. So very simple, time is given in 5 minutes, so we have to convert that into second. Apply the formula, that is nothing but rate is given as change in concentration by time. So what is the change in concentration? So from 2.2 to 0.05. So therefore we can get the change in concentration, nothing but 0.15 molar. Next, time 5 minutes into 60 seconds, we will get 300 seconds. So therefore the final answer is 5 into 10 to the power of minus 4 mole per liter per second. So hope you have understood question number 4. So with this we complete the first part of chemical kinetics, that is rate of reaction theory as well as the numericals related to this. So hope you have understood this. Thank you so much.